and welcome, I'm your CodeMonkey. Welcome to the free advanced section for my complete C# mastery course. By going through this course, you'll be able to make games, websites, apps, robotics, and literally anything. C# is an extremely versatile language. This complete course starts from the absolute basics like how code executes line by line and what is a variable, then covering some intermediate topics like what are interfaces, generics, and events, and how you can use them to build some really awesome things. You will also learn the theory behind how to choose good naming rules, clean code guidelines, and learn about design patterns. And finally, in this advanced section here, this one covers some very interesting topics like reflection, async programming, and multi-threading. This free YouTube video over here, this one contains all of the video lectures for the advanced section. Like I said in the previous video, my goal was to publish the video lectures here on YouTube for free if the premium version sells above a certain number of copies. And I'm happy to report that it has indeed sold above that threshold. That's why this free video is here right now. So thanks to everyone who can afford it and who did pick up the premium version. I've already posted the 2 free videos with all of the video lectures for the beginner and the intermediate sections. And now here we have the advanced section. The premium version of the course has all the video lectures for all the sections, and also has a bunch of really nice bonuses. So speaking of that, here are the bonuses for the premium version. I came up with some that I think are really awesome, and definitely worth it if you can't afford it, while at the same time not putting any knowledge behind the paywall, so even people who can't afford it, they can still learn from the free video lectures. They really just need to do a little bit of extra work themselves. The premium version is really just selling convenience, making it really easy for you to truly gain the knowledge. The premium version comes with a companion project. This is a Unity project that contains a bunch of extra content. Basically, the video lectures, while being pretty massive themselves, they're still really only half the course. The other half of it is inside of this project. It has a bunch of custom edited windows to guide you through each lecture. And each lecture has a section on frequently asked questions. These are common questions that have some really detailed answers that provide even more details on what is covered in the lecture. Then there are some quizzes. These are multiple choice questions. Again, all with very detailed answers. It's really not just correct or incorrect. If you pay close attention to each lecture, you should be able to get most of these right. But whether you do or don't, by reading the extra explanation that will help you truly learn that topic. Then the interactive exercises, I'm really happy with this feature. I think this will really help you learn. Learning by doing is always much better. And these exercises encourage you to put what you learned into practice instead of just blindly watching the video lectures. I designed a ton of handcraft exercises for all the lectures to help you put into practice and truly learn the contents of each lecture. There are all kinds of exercises. Some are about spotting and fixing errors, others are about asking you to define some function or class or implement some kind of logic. There are some where you just write code, and some where you write code and then play the code in Unity in order to complete the exercise. Then each exercise also contains a hint just in case you get stuck, or a solution in case you get really stuck, as well as a video walkthrough of me going through that exercise and completing it while explaining everything in detail. So if you're the kind of person who gets stuck in tutorial hell, then I truly believe that this will really help you escape it. In order to learn, you need to actually do things, and these exercises encourage you to do that. They encourage you to do it as opposed to just blindly watching the video lectures. Then the companion project also has a companion window. Basically, this window is also listening to a bunch of errors, and if it finds one, it will help guide you in the right direction. I manually wrote a ton of text for when it detects lots of errors, all of them based on common errors that I see people ask about in comments in my own videos. So this should help prevent you from getting stuck in your learning journey and allow you to get help instantly. Then the course also has an AI to help you answer questions. This one was trained on the contents of the course and my own knowledge, so it should be very accurate and helpful. But more than that, it's simply the fact that it is extremely fast. You post a question in the course comments, and within a few minutes the AI will respond with probably a very good answer. Although of course, I myself will also still be answering all the questions manually. The goal with this AI is really speed, so you get a response almost instantly, and then within the next few hours I will manually answer myself. Then a simple bonus is how the premium version has the course split into lectures, as opposed to here on YouTube where it will be one giant video. It has to be that way due to how the YouTube algorithm works. This is a small thing, but it can be helpful, especially if you take your time to slowly go through the course just like you should do. Remember that the only goal is really that you are actually learning yourself. It does not matter how quickly you go through it. So separate lectures help with that so that you can pause and actually try out your knowledge before going further, and you don't have to memorize specific timestamps. And over here on YouTube, the videos have the normal YouTube ads as usual, whereas the premium version has no ads, so there's nothing to interrupt you while you're learning. Another 2 great bonuses is the private Discord and the live study group. You get access to a private Discord with a really nice community of people all on their own learning journey. I'm there myself as much as I can to answer questions or really just chat. And every week I also do a private live QA. You can join me on the live stream and ask anything you want, and I'll do my best to help. So these are the nice bonuses that I came up with that I think are really nice and really awesome while not taking away anything or putting any knowledge behind the paywall. If you can afford it, then I highly recommend the premium version. These bonuses will help you truly learn, and learn much faster than the 10 years that it took me. But if you can't afford it, that's okay. Like I said, there's no hidden knowledge hidden behind the paywall. You really just need to put more effort in yourself in order to actually apply the knowledge that you gain. So whether you get the premium version or watch the free lectures, I really hope you'll learn a lot. Also, just in case you're new to my channel, so a bit about me and my credentials or why you should listen to what I have to teach. For me, I've been programming for over 25 years and specifically using C# for over 10 years. I'm a professional indie game developer with several successful games published on Steam covering a wide range of genres. My games are usually focused on complex systems since I am primarily a programmer. It's what I really love to do and what I love to teach. Also, a couple of years ago, I started over here this YouTube channel making free video tutorials to basically share my knowledge to help you learn how to make your own games. There's already over 800 free videos over here on this channel if you want to continue learning beyond this course. Or look at my other courses. If you want something on making a specific game, you can watch my free Kitchen Chaos course. In there, we build a game from start to finish, and then on a second video, we add multiplayer onto it. Then for something more intermediate, for that, check out my turn-based strategy course. This one includes a really nice turn-based strategy game with actions and enemies and all kinds of things. Or if you're an advanced user, if so, then check out my Unity Dots course. Unity Dots is an extremely powerful, very advanced toolset that can help you write code that runs literally 100x faster. Or in general, for Unity, you can check out my Ultimate Unity Overview course. This one covers over 70 tools and features that Unity has. Also, even though this video is for advanced users, let me reiterate my usual advice for pretty much anyone trying to learn. That's really just take your time, take it slow. Remember, this is your learning journey, it's really no one else's. So the only thing that matters is that you learn. It does not matter how long it takes you. It does not matter if someone else learns faster. You're really not in competition with anyone but yourself. Remember, you are not expected to go through this entire course in 1 week or even 1 month. Like I said, this course contains knowledge that took me over 10 years to gather. So take it slow, take your time, really just focus on learning. And just one final request, if you find this video helpful, if it helps you on your learning journey, if so, go ahead and hit the like button on the video and subscribe to the channel. It's a tiny thing, but it really does help. Alright, so let's get to it. Hello and welcome, I'm your CodeMonkey. Alright, so here let's see a quick overview of everything we're going to learn in the advanced section of this C# course. This is going to involve a lot of very interesting, very unique topics. We're going to start off with an interesting advanced topic that I actually only started seriously using just recently. It's reflection. I had to learn this myself in order to make the exercise for the companion project. Reflection is how you can dynamically inspect your code and work with it without directly calling any functions or reading any fields. Next is going to be a simple but interesting one. It's how you can make some function extensions. This allows you to extend a type with more functions without having to modify that type itself. This is really useful when you don't have access to the type itself, when you don't have source code access. Then we're going to learn about static constructors. These are kind of like the normal constructor, but they run just once for the entire class. After that, we're going to learn about the type of keyword. This lets us get a system.type object of any type that we have. This is very important to use alongside reflection. Then a lecture on name of. This one helps you get a string name for some kind of type. This is really useful to help you avoid strings in your code. Next is the size of operator. This one lets you get the size of your types. Like for example, you can see how an int is 4 bytes, a short is 2 bytes, and a byte is just a single byte. So this helps you know how much memory your code will use. Then a lecture on default. Simple and very useful way to get the default value of some type. If you do the default of an int, you get 0. If you do the default of a bool, you get false. If you do the default of some object, you get null, and so on. So using this keyword is much better than hard coding some default values. After that, we're going to have a lecture on expression-bodied members. This is a really interesting, very compact way to write simple short functions. There's no need to write all the usual function boilerplate code. This one is basically just a lambda. After that, we're going to see a lecture on records. This is a super simple way to create immutable types to organize your data. Next, we're going to learn about the null conditional operators. This is how you can easily test for null before doing something, like for example, before firing off an event. Then a lecture on the null coalescing operator. This one lets you quickly test against null, and if it is null, return a default value. After that, we're going to learn about the ternary conditional operator. This is an excellent, super compact syntax for making a very simple if. You have the condition with an if and an else, so it's all very tiny, very useful. Next, we're going to learn about the main function in a console app and how to pass in some command line arguments. This is a really important one because there are many interesting programs that you can build that don't need any kind of UI. So a simple console app that you can control with some command line arguments, that one is always going to be an excellent option. Then a lecture on nullable. This is how you can make any type support null. Even value types like int or bool. You can make them nullable to support null. This can be much better than having to predefine some special value, something like -1. Next, we're going to see a lecture on span. This is a super efficient way to do logic on arrays or slices of arrays. Importantly is how this does not actually create any new data. It does not cost any new memory, does not create a new object. This one is basically just a pointer, meaning it is insanely performant. Then a lecture on bitwise operators. This is how you can work with individual bits of data. In this lecture, I'm also going to teach the basics for how binary works. Next, we're going to learn about enum flags. This is how you can turn your enums into bit masks, which then allows you to make some interesting combinations. Then a lecture on pre-processor directives. With this, we can give orders to the compiler itself. We can define symbols and include or not include some code in the compilation. Next, a lecture on the keywords ref, out, and in. These are really useful. They help you get more data out of a function than just a single return type. And they also help you work with types as references, even if they are value types. After that, we're going to learn about data boxing. Now, this does not have anything to do with punching people. It's really all about putting data inside a box. This is an interesting property based on the fact that everything in C# extends from object. Next, we're going to learn about dynamic. This is a really interesting, very advanced topic. With dynamic, we can work with types that don't actually exist. So we can define something as dynamic and call functions or read fields on that type, on that object, even if they don't really exist. That validation logic is only going to run at runtime, not at compile time. So this dynamic, this is really useful, especially when working with data you got from some kind of web server. Then a lecture on the class indexer. With this, you can make your own custom types, support access through an index, just like a list or array. You can add whatever logic you want and make it read-only or read-write. Next is a lecture on attributes. With this, you can add metadata to your code. Then that metadata can represent whatever you want. You can use reflection to analyze it and do something to it. After that is a lecture on anonymous types. Really interesting, quick way of organizing some data without having to first define a specific type. You just do new, open up the curly braces, and it will automatically create a generated type. Related to that is the next lecture on tuples. These are very similar. They also allow you to organize some data without first defining a type. In this lecture, I also covered the differences between anonymous types and tuples. Next is going to be a lecture on using idisposable. This is a really interesting code block and interface that helps you make sure you don't forget any kind of cleanup code. After that, we're going to learn how to create custom override operators. Using these, we can add support for our own classes to do things like addition or multiplication. We can define the logic of what exactly it means to add two custom player classes together, and also define the logic for comparing two custom types, meaning defining the logic for what exactly does it mean to do an equals. Next is a lecture on link. With link, we can easily do query operations on any collection of data, whether it be a list or array or some XML or some kind of database. We grab that data, then we can query for some conditions and select just a few elements. We can sort some things, we can do a union and so on. If you're familiar with SQL, then link will be quite familiar. Afterwards, we're going to learn about WinForms. This is how you can make visual C# programs. You have your toolbox and you just drag and drop the components. Here, I'm also going to talk about the other visual program tools, things like WPF and .NET MAUI, as well as how Unity itself doesn't have to be used just for making games. You can make normal applications with Unity. Next is going to be a lecture on DLL import, the library import, how to use extern and work with the Windows API. So this one is going to be a great lecture to learn how to interact with external libraries. Then a lecture on asserts and unit testing in general. With this, you can validate your own code to make sure everything is behaving exactly as intended. Next is going to be a lecture on writing unsafe C# code and working with pointers. Now this is a very, very advanced topic. Technically, if you know what you're doing, you can make some impressive stuff with unsafe code, but C# has a safety for a reason, so definitely only use this wisely. Then we're going to learn about asynchronous programming, specifically how to use async, await, and task. This is how you can have some code that takes some time, like for example, contacting a web server, and keep waiting for a response without blocking your program. This is extremely important in making sure your program feels nice and responsive. After that comes a super important advanced lecture. This one is all about multi-threading. This is how you can take advantage of all the cores in the CPU to make them all do work at the exact same time. When done properly, you can get some insane performance improvements, but it is also very, very easy to make mistakes. So this one is very much the definition of an advanced topic where you must know exactly what you're doing. And yep, all of that concludes the advanced section of this course. As you can see, we're going to learn about a lot of very advanced, unique topics. Some of them you're going to use quite often, and some of those probably less often. But just by learning about them, learning that they exist, that will help you whenever you need to use them. And of course, remember how you can always come back to this course at any time. You're really not expected to memorize all of this. Personally, I Google things all the time, and now actually I have this course in my own words. So anytime that I need to relearn some syntax, I'm really just going to rewatch the lecture to learn myself. So if in the future you want to remember something, like for example how async programming works, you can just come back here and watch that lecture. Alright, so this is everything we're going to learn. So let's start learning some advanced topics with the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn all about reflection. This is a really interesting topic for how you can analyze and run code in a dynamic manner. So reflection is a name for a bunch of functions that you can run on the types themselves. Like for example, over here I've got an exercise class, and inside I defined a myFunction function. And yep, all this is valid code. Now up here, constructing an instance of exercise, and through that I can simply call my function, and yep, everything works. So no errors, all perfectly fine. This is the usual way for how you call some kind of function on some type. However, another way is using reflection, and the way we do that is first we access the type itself. So we do that using the type of keyword, and then we use the class name. So in this case, I want to access the things on the exercise class. And then just by pressing dot, over here we can already see a bunch of really interesting functions. So get member, get interfaces, get nested type, get properties, and so on. So we've got all kinds of things. In this case, we're looking for a function. And again, technically the terminology in C# is a function is called a method. So it's called a get method. This one takes in a string for the name of the method that we're looking for. So in this case, we're looking for something called myFunction. So yep, just like this. And now this one is going to return an object of type method info. So method info. And this one, by the way, exists inside system.reflection. So let's add that using. So the method info for the myFunction method info. Okay, so basically now this contains the data that relates to this function. And now using this, we can invoke it. So we can call the invoke function. And this one takes in an object for the target. So in this case, let's use our created exercise. And then for the parameters, in this case, this function takes no parameters. So let's just put out an empty object array, just like this. And if that's it, this works. So let's just put a console.writeLine over here, just test it out. Test it out that we're calling myFunction. So we should be able to call it over here and also over here. So let's run. And if there it is, exactly like that, the function ran twice. So yep, here you have two very different methods of running the same code. And over here, you might be wondering, where exactly is this useful? I mean, just calling the function directly, that sounds much easier. Now, reflection is actually a topic that I myself had to learn quite a lot in order to make the interactive exercise for this course. For example, this exercise on the class lecture, the goal of the exercise is to define a player class. And basically, in order to test if the student has completed this exercise, the code needs to check that the class does exist. So for example, over here on this testing code, let's do the exact same thing. So let's assume the exercise, the goal over here is to define a player class defined inside of this one. Now, if it does exist, then obviously we can just access it. So we can just access the exercise type, that works. And if over here we define a public class player, if we do this, then yep, over here we can access player. And yep, so this does work, this is valid code. So we can do a type of in order to find. So if this type is not null, if so, then yep, then the type has been defined. However, by using this code, remember how in the beginning of the exercise, the player class does not exist. So if I raise this as to what this would be on the state in the beginning of the exercise, if so, obviously this code does not compile because there's no such thing as a player class. Basically, we cannot write code assuming something is going to exist when in reality it does not exist just yet. So really the solution to this, and the solution for the validation logic for pretty much all exercises, the solution is to use reflection. Like I said, reflection is really just a name of various functions that work directly on the types. So for example, we can access just the exercise type, just like this. And then let's just do a dot, and now we can see a whole bunch of things. In this case, for this exercise, let's say we want to find a defined player class. So for that, we can use the function getNestedType, and this one takes a string of names. So let's look for a class named exactly player like this. Now we can indeed write this code, so there are no errors, because again, we're just using a string in order to identify the player class by the name itself. So this is valid code, we've got no compiler errors. And this function is going to return an object of type type. So we can do type player type, we can do this, and then we can do a console.writeLine if this one does exist. So let's just print out just the player type. So let's see this. And if there it is, it prints out nothing because there's no player type. But if over here we define it, so public class player, if we define it like this, and if now it does indeed find that class. So by using reflection, we can write some code that tests if something exists before that thing actually exists. Alternatively, instead of looking for a specific type, we could also use the other one, so type of for the exercise, and we can call getNestedTypes. This one grabs all the types. It returns an array of types, so we can just do a simple for each on all of this, type, and all of these. We can look for them, and then let's just print out the type, all the types. So over here, if we've got the player, then some kind of unit class and some kind of enemy class and so on. So if we test this, we should be able to see all of them. And if there it is, we've got the first player over there, then player, unit, and enemy. So on pretty much all of the reflection functions, you always have one to look for a very specific thing, or one to look for all of them. And also on both these functions, you also have all kinds of filters. So there's a function that takes some binding flags, and these binding flags are really just filters. The main ones that I used quite a lot in the exercise was looking for static things. So for example, on static, or for example, this one non-public. Because for example, if we don't assign this, and let's say we mark these as private, if we do it and we run this code, and if there it is, our cycle only found the player class because it is the only one that is marked as public. So in order to find things that are private, if so, we need to use the binding flags. In this case, to find that one, we need to look for non-public. And by the way, if you want to implement multiple filters together, if so, you just need to write a pipe. So that's just a single pipe. This is the bitwise OR operation. So do this, and then we can add another one, like for example, looking for static. So right now, since we defined the filter, this is only going to find things that are non-public or static. Meaning in this case, it will not find the player, but it will find both these. And let's just erase this just to not get confused, and let's test. And if there it is, it's done like that. Finds the unit and the enemy, but no player. So yep, you can use either of these methods in order to find a specific type somewhere. So for example, some kind of player type. Okay, we have it. So we have this player type right here. We can just test this one against null. If this one is not null, then the type does exist. And if it does exist, then again, like we saw previously, we can find and call some kind of function. So for example, over here, public void, call it my function. And then by using the player type, which by the way, another note, we can get the player type either like this, like we did, or also again, using the type of keyword. This one returns a type. So basically player type or type of, in this case, since exercise.player, since this one exists, we can do this. So basically both these have the exact same thing. Okay, so then using the type, we can call get method, and let's find our function. So let's find the my function. This one returns a method info, my function method info, and then we can invoke it as usual, except over here, we need an object. So let me just do a new player. I'm going to talk about how you can dynamically create objects in a little bit. So over here, new exercise.player. And then this one has no parameters, so an object, an empty object array. And yep, so this is basically going to run this. So console.writeLine, and we can run my function, and we can see, and yep, exactly, it found the player and ran the function on the player. So yep, all this works. And again, over here, we don't have any direct calls over here to my function. If we select this and we find all references to this, nope, we do not find any references because the code is not being directly referenced. Instead, we're referencing only through reflection. Now, like I said over here, the second parameter, this one is for all of the parameters that this function takes. And just in case you don't remember, object, this is the base C# class. This is basically the base type that all of the C# types inherit from. So this can be anything. So for example, we can define a function with an int parameter, and then over here we can call like this. So we can do this, and then print out that one, and let's see. And if it does work, my function and did receive that one. Although of course, we need to pass in the correct type. Since over here, this is an object, this has no limitations, so we could pass in, for example, a boolean, and there it is, we have an error. We passed in a boolean, which cannot be converted automatically into an int32, which is what the function expects. So even though this is of type object, obviously the types need to match whatever this function expects. And through the method info, we can get pretty much all the info for this function. So for example, through that one, we can get, for example, the return type, and this is going to return, over here in this case, it's going to return void. Or alternatively, we've got all kinds of things. You get the parameters. This returns an array of parameter info, which again contains all the data for all the parameters. So the type, the name, and so on. Again, all of these are things that I use in making pretty much every interactive exercise. There are various exercises that require you to implement a specific function that returns a specific type with a specific number of parameters. So that's pretty much how all of that code works. If you want, you can actually inspect the code for the exercise completion. So you can start an exercise, like for example, this one on defining a player class. So the goal on this one is to define a player class and then define some functions inside of it. And in the project files over here, you can see inside the exercise folder, you see a bunch of files related to the exercise that you have enabled. So in this case, let's open up the exercise scene tester. And yep, over here, if we scroll down, we can see all kinds of reflection being used to make this exercise work. So for example, over here, it's going inside the exercise class and looking for the nested types in order to find the player class. And if it does find it, then it goes inside all the methods within that player class in order to find a say hello method. And if so, then basically, yep, the exercise is completed successfully. For another practical example, you can, for example, just look at the Visual Studio IntelliSense. So if we write some regular code like exercise.player and then put a dot. So for example, if over here we construct a brand new player. So we have a player and then we access the player and we do a dot. And yep, over here, this is basically using reflection. Visual Studio is going through the entire type over here behind the dot, and it shows all the fields, all the functions, and all the events related to that type. So using reflection, you could build something like IntelliSense. Another thing is how code in C# is grouped into assemblies. So for example, let's grab the type of our program type. So that's the default one up here. We can grab that one and grab the assembly. Let's just do a console.writeLine on this one. So let's just print this out and see. And if there it is, that is the name, that is the reference for our assembly. Which again, inside that assembly, that returns an assembly. So inside that one, you can then put a dot. It can get all the types, all the files, all the things, everything that exists within that assembly. Also, if you want to look for any types inside of an assembly, of course, as usual, you can cycle through the types and print them all. But if you're looking for a specific type, if so, then over here on the name, you need to write it exactly as the assembly writes it. So if we print to see what this one up top writes, yep, this one says CodeMonkey C# course, which is the namespace, then the program, so we're inside the program class, and then for example, the exercise class, and then the player class. Again, note the dots and the pluses. If I wanted to get the player type over here, if I were to just write exercise.player, so if instead of this, I just write this, so just exercise.player, if I do this, then nope, it does not find it. In order to find it, over here when you call getType, it needs to be called with the exact same full name, including the namespace. Including the namespace and also including over here the dots and the pluses. If we do this, then yep, now this one does find it. So one more thing is like I mentioned a while ago, which is dynamically creating objects of a certain type. So for example, over here, we constructed a brand new player and we use that to invoke the method. But again, if this code was written before the player class existed, then this would not be valid code. So we need to also dynamically create an object of that type. So over here we have the player type that we dynamically grabbed. And now with this one, we can create it. And for that, we use the class called Activator, exists inside of system. And then we call create instance. And then we can either pass in strings for the names, or if we already have access to the type, let's do that one. So let's just pass in the player type. And yep, this one is going to construct a brand new player object. This one is going to return of type object, because again, we're running this before, let's say, the player class is defined. So we need to use the generic object, so player object. But then again, over here on the invoke, this one also takes in an object for the target. So we can pass in the player object. And yep, so now this one is going to create an instance of our player type. So it's going to create a brand new player object. And then we're going to use that player object over here to invoke the function. So if we run this, and yep, everything works as usual. Now, yet another interesting thing about reflection is how you can bypass access modifiers. So for example, over here for this function, instead of making it public, let's make it private. So in this case, even if you have access to this code right now, if so, if we go inside exercise.player, if we construct a brand new player, and then we go inside player and try calling my function, and nope, this does not work, because again, like it says, this is inaccessible due to its protection level. So if you have a private function, you cannot call it, you cannot access it through regular code, that's the usual thing. However, you can still run it over here through reflection. So if we run this code, it still works. We just need to make sure we find the actual methods over here for the binding attributes. And we need to make sure to find the function. So over here when looking for it, since this one is private, let's make sure to add the binding flags for non-public. And also for this one, we also need to add the instance because this is an instance function. So if we run like this, even though the function is private, yep, that one still ran the function. So by using reflection, you can run private or internal code. Now again, do keep it in mind, this is probably not something you should do in your own code. If you make something private, then you probably want it to actually be private. But for example, if you're making some kind of testing code, if you're doing test-driven development, if so, you probably still want to test your private functions. So if so, then reflection can be a use case for it. Or another example is when working with some APIs, like for example the Unity API, where some functions might be marked as private or internal. So in those cases where you cannot directly modify the code and you really need to call that function, if so, remember how you can do it through reflection. Related to that is also doing things like modding and plugins. You can allow your game to dynamically load a DLL at runtime and then use reflection to run the code inside that library. So that's reflection. It's a very interesting topic, definitely very niche in terms of use cases. Like I said, I really only had reason to learn about it right now in order to make the exercise for this course. So it's probably not something you're going to use regularly, but do remember that it exists. Remember how there is a way to dynamically run your code if you need to. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn about function extensions or extension methods. This is a really interesting C# feature that allows you to extend classes without having to modify the code in that actual class. So usually if you have some kind of class, like for example over here I've got a myTransform, If you have it and you want to add some kind of function to it, usually you just modify the class and write the function inside of it. So for example, a public void move right, and then over here would take the position and increase to the right, something like this. Okay, so yep, that works. Here is the function. And up here, if we have something of type myTransform, if so, then we can go inside of this and we can indeed call the move right function. So yep, this works. This is perfectly valid code. We have modified the class to add our custom function and then we call the function. However, what happens if you can't modify it? Like for example, let's say I do want to implement this kind of move right function. However, instead of making it work with my custom myTransform type, instead of this, I want to work with the built-in Unity transform type. Now that type is sealed, I cannot modify it. So I can put transform for some kind of transform and we can try going to the definition. So here it is, except this class is compiled, meaning we do not have access to modify this. So the method of just writing the brand new function directly inside this class, this does not work because we cannot modify this class. So that's exactly where function extensions come in. Which again, remember how function and method are pretty much interchangeable names. So if you look in the C# docs, what we're talking about here is actually technically named extension methods. So extension methods or function extensions. This is basically how you can add extra functions to some kind of type without having to modify that actual type. We just need to follow a bunch of rules to make it work. The first thing we need is to be working on a static class. So let's make a static class. And then usually the naming rule is to name it something and then add extensions onto it. So in this case, we want to add some function extensions to the transform type. So let's call it transform extensions like this. That's the first rule. The second rule is the function needs to be defined as static and be public. So over here, a public static void, call it move right. And finally, the third rule, for this one over here inside the parameters, the very first parameter, this one needs to have the this keyword. It needs to have that and then be the parameter of the type that you want to extend. So in this case, we want to extend the transform type. So let's put it transform like this. And if that works, so this is now a valid function extension. And now inside of here, we can do our regular code. So for example, we can do exactly what we're doing. So let's go inside this transform and modify the position and do a new vector 3 and just move it to the right. And if there it is, this is our function extension. And now up here, when we have access to a transform, like for example, the transform that this object is attached to, we can go through that one and we can call the function move right, and yep, it does work. And we can see over here IntelliSense is telling us, yep, this is an extension function. So we can call this, and yep, this works perfectly. So we've got no errors. Basically, what is happening here is this keyword over here inside the function. This says that this first parameter is special. Basically, it assigns what it was called on and uses that over here on the first parameter. So basically, over here, this is doing the exact same thing as if we were to manually go inside the transform extensions, call the move right function, and pass in this transform. So both of these are doing the exact same code. The only difference is this one is much easier to use. So yep, as you can see, like this, we have added a brand new function onto this type, onto our transform, without having to modify the transform type itself, so we don't need any access to it. We just need to know the type and we can write an extension and then we can write some kind of code that works directly on that type. And of course, over here, after using this special parameter, so this parameter, this one has to be the first one, but afterwards you can add whatever you want. So let's say, for example, a float amount, and over here we modify this one by the amount. And then when calling it, we just pass in, for example, 3. And yep, this works. So we call the function extension, which is going to call this function. For the transform, it is going to use this one, and for the amount, it is going to use this one. And again, this works on any type. So over here, we are making a function extension that is extending the transform type. But for example, let's do another one. Again, we just need to make sure to mark it as static. And let's extend, say, the bool type. Let's make is true. This one returns this, bool. And for example, just return if the boolean is true. So yep, again, all the rules are being followed. It's inside a static class. The function is static and has this keyword. So now up here, bool, and we can set it to something. And then bool.isTrue. And yep, this does work. So yep, we can add function extensions to some custom types. Or we can add to built-in types, can be a boolean, can be an int, can be literally anything. All of this works so we can easily extend any type with any functions we want. This works for extending classes, but also works for extending value types, like we saw over here, the bool. So we can also extend structs, and this also works for extending interfaces. So if you want to add extra logic to a type, but either you cannot or don't want to modify the original type, that's where function extensions or extension methods come in. It's one of the best ways to make some helper utilities functions that you use a lot and make them super easy to use. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn about the static constructor. This is a really useful way to run some kind of initialization code where you can be perfectly certain that it will always run. Okay, so you're already familiar with the regular constructor. So we have the class and then we have a constructor, and this code is going to run whenever a new object of this type is constructed. So basically before you use this type at all, before you use any functions or fields, before that you can make sure that this code always runs. And static constructors are basically the same thing, but just in a static context. And the way that you define them is super simple. You just use the static keyword with no access modifier, so no public, no private. This cannot be either one of those. You cannot manually run a static constructor. It always runs automatically. And then it must have the same name as the class, so player. And it also must have no parameters, so a completely parameterless constructor. Also, you can only have a single static constructor, and it cannot be inherited or overloaded. So it has a ton of limitations, because like I said, this one runs automatically. So that is why we cannot have any parameters over here, because the compiler is going to run this automatically whenever we need to. And basically this will run either when an object of this type is created, so for example before the constructor, or also when any static data or any function is accessed. So for example, let's do a console.writeLine here, just to see when this runs. So the player static constructor, and if we run like this, so we have our player class, we've got the constructor, the static constructor, and up here we are just constructing a brand new player. If we run this code, if there it is, it ran first the static constructor and secondly ran the constructor. So the static constructor always runs before the object is constructed. Now let's say we have some kind of function, so a static void for some kind of test function, and over here same thing, let's do a console.writeLine on our test function. Okay, and now up here before we construct, let's go inside the player and call the test static function. Let's do it like this, so let's run. And if there it is, again, same thing. The static constructor ran, then the test function, and then the constructor. Also note how the static constructor only ran once, so when we construct an object, it did not run a second time. Or alternatively, if we have some kind of field, so a static int for some kind of int field. If we have this, and up here we read it, so let's do console.writeLine. Let's write line on the player.I, so our static field. So by default, if we don't assign any value, this is going to default into 0. So over here, if we set I equals something, let's see what this one is going to print. So is it going to print the 0 that is over here by default? Or is it first going to run this code and basically print 56? So let's test. And if there it is, exactly like that. So as soon as we access the static field, as soon as we do that, before it actually runs that code, it is going to run the static constructor. So first runs that one, then prints the value, which in this case was assigned the static constructor, and then again runs the function and the constructor. And same thing, the static constructor only ever runs once. Meaning that the static constructor, this is really excellent for doing any initialization logic that this particular class might require. One example is exactly this, is if you have a static field and you want to make sure to initialize with some data. If so, you have two options. So basically over here, when you define it, you can also assign it some value, or alternatively, you can assign it on the static constructor. Both are valid options, pretty much just like on a regular constructor. You can also have some kind of regular field. So you can have that one, and over here you can assign it some value, or inside the constructor you can assign it some value. So you've got these two options for non-static context, and you also have these two options for a static context. Now the static constructor, this one can also be very useful for debugging. You can basically place a log over here, and it will let you know when this class is used for the very first time. Whereas if you were to place the log only on the constructor itself, if so, then this would only run when an instance of this type is created. Whereas for the static constructor, that runs whenever any object is created, or when any static element, like a field or a function, when any of those are accessed. So the static constructor, this one guarantees that it always runs the very first time that this class is used in pretty much any way. It is also important to know how in the context of multi-threaded code, the static constructor is guaranteed to be thread safe. Meaning if you have multiple threads and all of them try to access some kind of data inside of this class at the same time, if so, the .NET runtime ensures that this class is locked, and make sure that the static constructor runs only once, no matter how many threads try to access it at the exact same time. So the static constructor is relatively simple to understand. Definitely use it whenever you need to ensure some initialization logic happens, and ensure that it happens in a static context and not just on a per object basis. Hi there, so quick intermission. Are you enjoying the course? Are you learning quite a lot? I really hope so. I hope you're paying attention. I hope you're taking it slow and really learning everything. Also remember to pause at the end of each lecture and dive deeper into each topic. I made sure to include the titles for all the frequently asked questions, all the quizzes and the interactive exercises. Those only show up at the end of each lecture, so you can use that to guide yourself. Or you can pick up the premium version of the course to get all that info in the really nice companion project. So if you can't afford it, you can use that page to dive deeper into each topic. But if you can't afford it, the companion project makes it really easy to keep on learning. Alright, so let's keep going. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to learn about the type of operator. This operator lets you get the type object of a certain type. Okay, so type of. Now we've actually already used this a few times in the reflection lecture and also on the one on typecasting. The way we do reflection is by accessing the type, and I don't mean by accessing the type name itself. So if we call just player, if we do this, nope, we are not accessing the type itself. This is not valid code. In order to access the type object, meaning the object of type system.type, the way we get that is with the type of operator, which works sort of like a function. So we write type of, then parentheses, and then the type within it. And if we do, then we can see that this does now return an object of type system.type. Like it says here, this represents type declaration, so class types, interfaces, arrays, values, enumerations, and so on. So this is the base type that references pretty much any type you can create. So now with this type object, then over here you can do all kinds of things. So you can get nested types, nested functions, and so on. So this is how you access the reflection that we already covered. Whenever you have some kind of function that requires a type object, meaning system.type, if so, then this is what you want to use. Like for example, when working with some Unity code, if you want to get the component attached to some kind of game object, you use the getComponent function. And this one actually has two versions. One of them is this one with the angle brackets, meaning this one is using generics. This is actually the version that I normally tend to use. So just put this, and then inside you put the type that you want to get. So just like this, it's going to get the component of type player. However, alternatively, you can also use the other version. So this one over here, which is non-generic, and note how instead of having a generic parameter, this one receives a parameter of type type. So this is where you would use it. If you were to use this and you just type in player, if you do just this, then nope, this is not valid code. Again, that's the difference between having an object of type player as opposed to accessing the type directly. So in order to make this work, in order to use a function that receives a parameter of type type, for this one we use type of, and yep, now this does return the correct thing, and this will return a component of type player. This is the one thing that you definitely need to remember. This is something that drove me crazy for a long time until I finally memorized it. Whenever you see something that takes a type parameter, whenever you see that, always remember you have to use the type of. Because yeah, for me it has happened many times where I see a function like this, I try to use it like this, and I have no idea what is wrong. And the reason that is wrong is exactly that. We need to do type of in order to get the object of type type, and now this does work. Or alternatively, like we saw on the lecture on typecasting, you can, for example, create an object of that type. So for example, making a brand new player. And another way to get the type of type player, if you have an instance of that type, you can just call the function getType, and yep, this is going to return the exact same thing. So if you have an object of a certain type, you can call getType, and if you don't, you can do type of and then pass in the class name itself. So yep, that's type of. It's very useful when you need to get the type object to use in some kind of code. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn about the name of operator. With this one, you can get the string name of a certain type or field or function. Okay, so name of. This is an operator, meaning you use it sort of like a function, so it's similar to the type of that we already saw. So you write name of, and then inside parentheses, you put the name of something that you want to get the name of. Now, the main benefit of this operator is to avoid using strings, which is something that I always highly advise you to do. You should never use strings to identify something. So if you want to reference the player class, if so, do not type a string just saying player. So don't do this, instead do something like this. So player class name, you do name of the player class. So instead of using hard-coded strings, use name of to avoid using strings directly in your code. This also helps avoid issues with refactoring. So if you have a hard-coded string kind of like this one, if you do this and you refactor, so instead of player, let's call this just a general unit. If so, then yep, now this literal string, this is now completely wrong. Whereas with name of, if you modify the name inside of here, the name of the actual type itself, if so, then what returns from this is going to be updated. Now, this works for classes, but also for fields and functions. So for example, let's actually do a log, just see what this says. So let's do a console.writeLine. Let's print out this one to see what this says. And let's also rename this back into player. Okay, let's test. And if that says, it says literally player. This gets just the string name for the class. Whereas, for example, if you do type of in order to get the player type, and then you convert that one automatically into a string. Let's see what this says. And if you get the type, then you get the whole thing in order to get to the type. Whereas with name of, you get just the name of that class, that type, that something. So this works with types itself, like these, but it also works for fields and functions. So we can do this, print out the player speed, and print out is grounded. And if we run this, and yep, this return exactly the name of those elements. So it can work with classes, with fields, with functions, and pretty much anything. One thing this is great for is, for example, for debugging. So for example, if you want to validate some kind of function, so over here, let's say a public void set speed in order to set the player speed. This one, let's receive an int for the speed, and then set this.speed equals this kind of speed. However, for debugging, for some kind of validation, we can add some extra logic here. We can say, for example, if speed equals 0, If it is, let's say this is an invalid value. So if so, let's do a console.writeLine. Let's print out to the console error. And then instead of hard coding saying speed must not be 0, instead of hard coding this, because again, if we were to modify this for the something like set speed and so on, if we were to modify it to something, then a hard coded string would not update. Whereas if we have the name of here, so name of and pass in this speed parameter, so this parameter name, if we do this, yep, now this will indeed work. So up here, let's create a brand new player and call player.setSpeed, and let's set it to 0. And if there it is now, that is correct. So error speed must not be 0. And if we were to refactor this, so speed to set, if we do this, and yep, now it correctly sets the parameter name exactly as it should be. So this can be really great for making your documentation a little bit more robust. Again, anytime you can avoid using hard-coded strings, that is always a better approach. And technically, this one also has a nice performance bonus. For example, if you already have a player, you can technically go and call getType, and then from type you can just access the name. So this works, and this will pretty much print out the exact same thing as here. So let's actually do that. So console.writeLine, and if there it is, this one prints out player exactly the same. So the one performance bonus is if you do this, if you access the object, you get the type and you get the name, or alternatively, you would just do type of the player type and then grab the name. Doing that, that code would actually run at runtime, whereas over here, the name of, this one is executed at compile time, meaning that when the code goes to compile this code, when it does that, the compiler replaces this line of code over here with a literal string. So as soon as you compile, instead of this code being right here, it will replace it with exactly this. So this is a tiny change, but still a nice bonus. So it's a tiny bit more performant. All right, so that's name of. If you ever need to get the string name of a class or field or function or anything, then use this instead of hard coding a string. This makes your code more maintainable and less error prone. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn about the size of operator. This one lets you see the size in bytes that are used in memory to store a certain type. Okay, so let's see the size of operator. Now this one returns the value in bytes of a certain type. Like for example, we know that ints are stored in 4 bytes, so if we have an int I, we know this is going to take 4 bytes. And we can test that. Let's do a console.writeLine, and let's print out the size of. This is an operator, so we use it kind of like a function, so kind of like the type of and name of. And this one takes in the type, so let's put in int, and let's see. And it picks out like that, 4 bytes. So we can see the size of an int. We can also see, for example, the size of a boolean. And yep, a boolean is only true or false, so this one only takes 1 byte. Or for example, let's see a ushort, which is a much smaller version of storing whole numbers. And if this one, unlike the int, this one takes just 2 bytes. Or on the other hand, we can see, for example, a long. And yep, a long takes 8 bytes. So yep, basically this one lets you see how many bytes a certain type occupies. Now this is extremely important for memory management. Memory management becomes really important when you're working with some very memory limited devices. Like for example, if you're doing something on some very old mobile devices, or maybe some IoT or embedded devices, or perhaps if you're syncing data in a multiplayer game. If so, usually you want to limit how many bytes you send over the network as much as possible. The less you send, the less it's going to cost in terms of bandwidth. So knowing that a ushort is much smaller than an int, that can be very helpful if the number you are trying to send across the network can't fit within a ushort. Or it's also useful if you're doing some specific low-level memory management where you need to allocate some unmanaged memory manually. This way you know that, for example, if you have 4 ints, you know how big that will be in memory. So as we saw, you can see the size of all of the built-in types, so int, bool, short, and so on. This way, if you have to store, let's say, 1000 ints, you know exactly how big that will be in memory. However, you cannot use size of on classes. So for example, if I put here of the type player, nope, this one does not work. So we cannot use size of in class like it says here. Player does not have a predefined size, therefore size of can only be used in an unsafe context. Now there is a lecture in the advanced section later on using unsafe. This basically removes all kinds of protection that C# has by default. So that's one option is you would use unsafe and then put this inside an unsafe. And if this would indeed work, you just need to enable unsafe compilation. Or alternatively, if you need to know the size of some kind of class, for that you can go inside the Marshall class, which exists inside this namespace, system runtime interop services. And inside you do have a size of, although this one has a bunch of strange limitations that honestly I'm not very familiar with. I'm definitely not an expert when it comes to marshalling data, dealing with bytes and all of that stuff. But over here, if we don't include this attribute, then this throws this error. It says cannot be marshaled as an unmanaged structure. No meaningful size or offset can be computed. And with that attribute, it does work. It does store it in 4 bytes. But then if I were to add something like a public list of ints for some kind of int list, if you do, then yep, that shows that same error again. So honestly, I'm not entirely sure how to make all of this work. I believe you have to use the marshal as and then marshal this field as some kind of unmanaged type, and then you have to select the one that is related to whatever type you're trying to marshal. But like I said, I'm not an expert in marshalling, so I'm really not entirely sure how this whole thing works. But basically you can use the standard size of to get the size of any of the built-in types. And then for classes, either use marshal.sizeof or put it inside an unsafe context. And for structs, this one also works. So you can do marshal.sizeof of some kind of struct that has some kind of data. Again, it can't have any kind of managed data like a list. But if we do it like this, give this print, the size of that struct is 8 bytes, which makes sense since it has. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn about the default operator. This one is really useful for when you want to assign a value to initialize something, but without giving it a specific value. Okay, so default. Now we've actually already used this keyword in 2 scenarios. So for example, we use it in some kind of switch. So you define something, do a switch on that something, and then do all kinds of cases. So case some kind of number, run this code. And if not, if it does not match any, then run the default case. So basically this is the code I will run if the value does not match any of the other cases. And the other scenario where we've also seen the default being used, for that was on the lecture on the optional function parameters. So if we have some kind of function, public void set speed, and this one receives an int for the speed, and if we want to make this an optional parameter, if so, we just have to do equals and then default it to some kind of value. So you can default it to a fixed value, or you can use default, the default keyword, which will return the 0 equivalent value for that type. Now there are actually 2 ways to use default, the shorthand and the normal way. Now the normal way is using the operator default, kind of like a function. So we do default, and then for example, we pass in the type, so let's say int. Let's do a console.writeLine on this to see what this says. Yep, there it is, 0. Like I said, default will return the 0 equivalent value of that type. So in the case of an int, the 0 of an int is indeed just 0. However, if we try to see the 0 equivalent of a boolean, yep, this one prints false. In booleans, you have either true or false, where true is usually equal to 1 and false is equal to 0. So for the 0 equivalent, it returns false. And then for class types, like for example a player class, for that class types, the default is going to be null. Remember the lecture on value types versus reference types? Value types always have to have a value. So when we do a default on something like an int, which is a value type, when we do that, we have to get a value. But references, like the player class, these can simply have a reference that points to nothing, meaning null, so default of any kind of reference type is going to be null. Now this is the quote-unquote normal way of using default. Use it as an operator with parentheses and then put the type inside of it. However, another way is just to let the compiler infer the type. For example, if we just define a float variable, if we do this, and then for assigning, we just assign it to the keyword default. And yep, that's it, no parentheses with float, just like this. And yep, this does work. So if we print out df, and if there it is, a float does default to 0, which is actually the exact same thing we are doing down here on the optional function. So we can just write default, or we can write default int, and yep, both these work exactly the same. Now, another place where default is very useful is when working with generics. So for example, if we have some kind of class for some kind of box, and this box stores an object of type t, then over here, let's do a public going to return t, and let's call it getDefault. So on this function, we want to return the default value that is stored inside of this box. Now, by being generic, that means we don't know what type t will be. Maybe it's going to be an int, or maybe a bool, maybe a player, we really don't know. So over here on this function to get default, we can't really just return 0, because again, t might be something like a player, and you cannot convert a player onto a 0. It can also not be false, it cannot be null, and so on. So in this, if we want to return some kind of default value, again, we can just use the default keyword, either with the shorthand or default t for the longhand. And yep, so now if we create a box of int, bool, and player, so for example up here, let's do a console.writeLine, let's do a writeLine, let's create a new box, let's do a box of ints, and then let's call the getDefault. Let's see what this prints. Let's create a box of ints, then a box of bools, and finally a box of player. Okay, let's see these 3 boxes. And if there it is, 0, false, and then null. So the same code now returns different default values depending on what generic type we use. Or alternatively, when using the ref and out keywords, I'm going to cover these in detail in a future lecture over here on the advanced section. If we were to do an out bool is set, something like this. Basically, the out keyword means that this parameter is an output parameter and must be set before the function ends. So again, for these, if you want, you can define some kind of default value. You can default to that, or you can just use the default keyword. So if you ever need a default value for something, instead of hard coding some value, you can just use the default keyword. It will use the 0 equivalent value of that type. Usually that is either the number 0 or false or null. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn about expression-bodied members. This is a way for you to write C# code in an extremely compact manner without having to sacrifice readability. Okay, so expression bodied members. Like I said, this is a very compact way of writing some code. For example, if I have some kind of player class and inside I have some kind of player name, and then I have a function that returns the player name, so get player name. So I can do this and then simply just return the player name. And if that's it, a very simple function. This is the regular normal C# code. However, we can make this quite a bit more compact by using expression bodied members. Basically, if you are familiar with the lambda anonymous functions, then this is basically the same syntax. So we define the function, and then instead of opening a code block, instead of that, we do a little arrow, and then we just put what we want to return. So in this case, just player name, just like this. So if that's it, this is the whole syntax, super simple. So basically this and what we had previously, both are doing the exact same thing. The compiler basically sees that this function returns a string, so it automatically adds a kind of return statement here. So this one does do the same as the other version, it just returns the player name. Now this method, expression bodied members, this is really only meant for extremely tiny pieces of code. In fact, you can't even do a code block with this syntax. So if I try opening and closing a code block, nope, this is not valid code. You cannot do a code block with this syntax, which means that this feature can really only work with single instructions. You cannot use this on things that require multiple instructions. You can use it like this in order to return some data from a function, but you can also use it to set some data. So for example, a set player name and receives a string for the player name, and we can do the little arrow and set this dot player name equals this player name. And yep, there you go, another perfectly valid function. Again, with the same limitations, this one can only have a single instruction. So if you need to do multiple things, you do still need to use the regular normal C# code block. But for super simple things like just getting and just setting, then this makes the code quite a bit more compact. In fact, one place where I've used this quite a few times is for function pass-throughs. Like for example, if you have some kind of class, and that class is really just meant to be a layer of abstraction for another class. For example, when I made a turn-based strategy game, I had some kind of level class, and inside that one, I was using the actual underlying grid system. And for some functions, I really just wanted to pass that function call onto the underlying grid system. So for this use case, this super compact function pass-through, this is a really great option. So here we can see how this works for functions, but it can also work for properties. So for example, if we have a public string player name, just a regular property, if so, we can do the get, and now normally we would write a code block. However, we can do the same thing, just a little arrow, and in this case return player name. So this is a read-only property, or we can also assign the set player name equals value. Yep, this is also valid code. Or you can actually also use it in a constructor. So if we have public player, define a constructor with some kind of string for the player name that receives on the constructor. So here we can do the little arrow, player name equals player name. And yep, this is a valid constructor code. However, again, the same limitation. This only works if the constructor has just one instruction. So for example, if over here we had two fields like vector3 for the position, if so, we couldn't set the player name and then set the position on the same line of code. So expression bodied members are really good for making some really compact code, but as always, you should never sacrifice readability for compactness. So personally, I really like how this has a whole bunch of limitations, which means that it can really only ever be used in situations where it should be used. If you have some extremely simple get and set functions, then this can be quite useful without having to sacrifice any readability. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn about C# records. This is a super simple way to create immutable types to organize your data. Okay, so records. The basic usage is actually incredibly simple. So first you write the access modifier, like let's say public, then we write the record keyword, and then some kind of name for this type, like let's say person, and then we open the parentheses, and we write our parameters. So for example, something like first name and last name. And yep, that's it. Just with this, we have created our person record. So as you can see, if you need to organize some data, it can be similar to just define a simple record as opposed to defining a whole class. So for example, something like this, so person class. If we had this, we would then have two properties, so one for the first name with a get and a init, meaning needs to be initialized, and same thing for the last name. So yep, basically over here, we have the exact same thing written twice. We have two pieces of data, which in the case of records, the underlying compiler, these are actually auto-implemented properties, and they are also immutable, meaning they only have a get and have no set, and also they need to be initialized. So yep, this super simple record is exactly the same thing as this. You can see how this is quite a bit easier to write whenever you need some kind of structure to hold some data. And then to construct a brand new person, you really just find person, and then you can do new person, or really just open up the new like this, and then pass in all the parameters. So in this case, let's say CodeMonkey. And if that's it, here is our brand new person. So we easily defined in just one line of code and easily created in this one. Then with this, let's do a console.writeLine in order to see person what this says. And if there it is, the toString automatically writes out the actual type, so person, and then all of the parameters and all the data they have. So yep, this is how simple records are. And now by default, records are indeed like this, meaning they are immutable, they have no set, they cannot change. Here, if we try creating a brand new person and then go inside the first name and modify it to something else, nope, this does not work. This one can only be set once it is initialized, it cannot be modified afterwards. However, if you really need to, technically you can make it mutable. You just need to define the record, and then instead of doing a semicolon, you just open a code block, and now inside you can define all the properties. So for example, first name, and on this one, let's put it with a get and with a set in order to make it mutable, and we just have to do equals first name in order to make sure that the value that it receives over here is the same one that is set to this property. So yep, like this, if we now do a person and go inside person and modify the first name to something else, yep, now this is indeed valid code. However, records really are primarily meant to handle immutable data, so you really should avoid doing this unless absolutely necessary. The fact that they are immutable is indeed part of the purpose. Immutability is really great for handling static data, especially when working with things like multi-threaded code. If you have multiple threads, all of them accessing an object that is mutable, it can cause all kinds of strange issues, all kinds of race conditions when multiple threads try to write to the same field at the same time. Whereas if a field is marked as immutable, meaning that data can only be read, that eliminates all those issues. Now if you want, you can also do something that is called non-destructive mutation, which really just means creating a brand new record based off another record. So for example, over here we can do person, call it person2, and we can start from data contained inside person, and then use the keyword with, then open some curly brackets, and now here overwrite any of these. So for example, let's say last name, set it to gorilla. And yep, just like this, so now we have person and we have person2. And if there it is, the first one code monkey, second one code gorilla. Now this is technically called non-destructive mutation because in reality it doesn't really mutate the original data. This one still stores the exact same thing, basically just creates a brand new one using the parameters from the previous one. Also over here we are really just using the record keyword. But what this is really doing is really the same thing as writing record class. So by default, records are going to be classes. However, if you want, you can also make it a record struct. Yep, this also works. So your records can be either classes or structs. However, in terms of equality, they mostly behave like structs. They mostly behave like value types. Meaning if we make this a record class, and up here, let's create two persons. So let's call it and person3. So here we're doing new twice. So technically these are two objects. So if person was a class, these two would be different because they are different objects. However, if we do a console.writeLine, if we do that and we check person equals person3, if we check this, yep, this one does return true. Now in a normal class, if this were a normal class, this would return false because these two are technically separate objects. However, since this is a record class, because that, the equality behaves more like struct, meaning it checks the underlying values for the equality. Again, this is because records are really primarily meant to be used for data organization, so the equality logic is all made based on that. Then if you want, you can also handle inheritance with records. So for example, we can do a public record, let's call it unit, and inside let's do some kind of float for some kind of speed, and then we can have a public record for some kind of player. This one receives a string for a player name and also a float for a speed, and this one then extends unit, and for the parameter, it passes in the same speed parameter. Yep, that's it, this is valid code. Also, one more note, technically records were only introduced in C# 10, and Unity is actually currently on C# 9. However, it does support records, but in order to make it work, it requires a slight workaround. So here I have some Unity code, and if I define, let's say some kind of record for a player, receives a string for the player name. So this is a record. However, if we do, we see this error. So predefined type system.runtime.compilerservices.isExternalInit is not defined or imported. So in order to make this work, in order to make records work inside of Unity, for that we basically need to create this type. So we need to put it inside of this namespace. So we need to create a class inside of a namespace. So let's do a namespace and name it like this, exactly like this. So system.runtime.compilerservices. Let's open and close. And then inside we need to define a class. And the class has to have this exact name, so isExternalInit, and define the class just like this. So it's all completely empty, it really just needs to exist. And if it does exist, then yep, this is now valid code. Alright, so records are an interesting way to very quickly define a type to hold some data. Instead of defining an entire class or a struct, you can very quickly define a record and have it with the perfect accessibility for some immutable data. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about non-conditional operators. These are two operators that help simplify your code by eliminating the need to do some null checks. Now, this is actually something that we already used in the events lecture. If you remember, for events, before you invoke the event, before that you need to test whether the event is null or not. Otherwise, it will throw a null reference exception if there are no listeners. And the compact way that I showed you for doing a null check is with this question mark. This is what is called a non-conditional operator. And basically, the code is executed from left to right. So when the code reaches the question mark, at that point it checks the left side. If this left side is null, if so, then this instruction terminates right here and just moves on to the next one. However, if the left side is not null, then it continues executing onto the right side as if this question mark was not here. So basically the question mark, this does a null check at this point, and on the right side you can write any code with the safe assumption that the thing on the left side is not null. Also, when I say that the instruction terminates here if it is null, what that means is that this whole thing gets evaluated into null. So for example, up here, if we do a console.writeLine, let's do a function to print something, so a public string, get player name, and let's just return a string, so something like this. And up here, let's just construct a player, so player, and actually let's leave it in null. And now we do player, then the question mark, and then get player name. So if player is set, if so, then it's going to return the player name. But if the player is not set, then this whole thing is going to evaluate into null. So if we run this, if there we go, it's empty, meaning that it's actually null. So we can test and verify equals null. And if that is indeed true, so if the left side is null, then this whole thing evaluates into null. Whereas if this one is not null, so over here, let's just construct a brand new player. So this one is not null. If so, then yep, it runs the entire thing and calls the function. And by the way, like we saw here, you can call any function after the question mark. So the standard that I showed you for the events is using .invoke, but that's just a event-specific thing. However, the question mark, the non-conditional operator, this one is not limited to just events. So as you can see, it works over here for the get player name and also works for fields. So over here, if we have a string player name, if we have this, and up here we can call the same thing, dot player name, yep, just like this. So basically it's only going to access this field if the left side is not null. And also you can have multiple of these in a single line. You can chain them together. So for example, if the player, if over here it had some kind of player for another target, if so, then you could do player question mark in order to make sure it only runs if not null, target, another question mark to make sure that it runs if it is not null, and then call take damage. Over here, pretty much the same rules apply. So basically, as it gets to this question mark, it checks the player. If the player is null, then it terminates the whole thing with null. But if it is not null, continues running the right side. And then it gets to this question mark and checks the left side. So if the player.target, if that one is null, if so, then again, it terminates over there. But if it is not null, then it's going to call take damage on the player.target. So the same rules always apply regardless of how many non-conditional checks you have. Now the second non-conditional operator is pretty much the same, except it's for index accessing. So for example, if we have a list of strings for some kind of player name list, if we have this, we can do, for example, player name list, do a question mark, and then the square brackets to access on some kind of index like this. So let's do a console.writeLine on this. And here the same thing will happen. So if the list is set to null, if so, then when it gets to here, it's going to stop evaluating. Whereas if this one is not null, so if it has something like, for example, let's say just one element, if so, then yep, it is going to go inside the list and grab it on this index. Like this does print CodeMonkey. And of course, you can combine both of them. So you can combine the one accessing strings and the one just accessing properties and fields. So instead of a list of player names, let's do over here a list of type player. So player list, and we have a new one. And over here, let's construct a brand new player. So now on this, we can go inside the player list. We can do the question mark and then the index, access on index 0, then do another question mark and call some kind of take damage function. So it checks the player list. If it is not null, continues running to the right side. It checks the one on index 0. If it is not null, continues running to the right side and runs the take damage function. So if over here, this element on 0, if this one is null, then it would safely stop the execution right here. However, this will still throw an error if the index 0 is out of range, so do be aware of that. And since the whole point of this whole operator is doing null check, it can only work on nullable types like reference types. So if we put, for example, int I and set this something, then I question mark dot compare to, nope, this is not valid. The question mark operator, so the non-conditional operator, this one cannot be applied to an int. Again, that's because int is a value type, so it cannot be null. However, if we make this into a nullable, so we add the little question mark, if so, then this does now work. So we can call toString, yep, this works. If you don't know this syntax, this is nullables, and I'm going to cover nullables in a lecture later on in this advanced section. All right, so that's the two non-conditional operators. Quite useful for very easily doing some null checks, and especially useful for making your event invocation much more compact without sacrificing readability. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn about the null coalescing operators. These two will let you easily test for null and return a value, or test for null and do some logic. Okay, so the null coalescing operator. Now this one is defined by two question marks, and the simple use case is for testing if something is null, and if so, returning some kind of value. So for example, here we have some kind of string player name, and then we've got a function to get the length of a certain string. This one receives the string as the parameter and just returns the string.length. And then over here, we're trying to get the player name length by passing in the player name onto that one and then printing it out. However, if we run the code like this, without assigning the player name to anything, if there you go, naturally we have a null reference exception. If we don't assign any value to a string, then that one is going to be null. So over here, we can add some kind of a null check. So let's find the player name, then if player name, if it is null, if so, let's put this one equals get the string length and pass in just an empty string. If not, then let's assign the player name length equals our string length. So we do a null check, and depending on that, we get one or the other. So let's see. And if now it does work, so without assigning an actual player name, just return 0. So no more errors. This code is working, and we can do exactly the same thing, but in a more compact manner using the null coalescing operator. The way you use it is, for example, by writing the player name, then two question marks, and then basically here we want whatever this is going to evaluate to if player name is null. So for example, we can do this, meaning that this will either evaluate to player name or an empty string. So if we use this instead and put it over here and just have one of these, yep, just like this. So basically this one, this instruction here, what it does is it evaluates the left side, left to the question marks. And if this one is not null, then this whole thing is going to evaluate to just this value. However, if the left side is null, then this whole thing is going to evaluate to whatever it is on the right side. So basically, if player name is not null, then it's going to call getStringLength to the player name. But if player name is null, then it's going to call getStringLength with an empty string. So now if we test, and if there we go, no errors, and it does return 0. And now if we give the player name something, so let's say CodeMonkey, and if now the exact same code also tests for the null check and now gives me the actual length of the actual string. So here we are doing exactly the same thing we were doing previously with the null checks, but in a much more compact manner. And I can also link multiple of these together. For example, let's find here a string for a default player name, and let's assign to something. Then over here we can do player name, double question mark, default player name, double question mark, and 0. So you can chain multiple of these together. If we run this code, yeah, there you go, it does return 7, which is exactly the length of this string. So basically this is going to execute from left to right. So if this one is not null, then returns this one. But if this one is null, then goes to the next one. And if this one is not null, then returns this one. However, if this one is null and this one is null, then it returns this one. So this operator is really useful for very quickly doing a null check and returning a non-null value. Instead of doing if-else testing for null, you can just write this and everything works perfectly. By the way, on the right side, instead of just returning a value, you can also run some logic. So for example, if player name is null, you can throw a custom exception with a custom message. Now the second operator, that one is the null coalescing assignment operator. In terms of syntax, it's exactly the same with double question marks. The only difference is that it has an equals at the end. So for example, if we have some kind of player class and a player field, if we try running some code on the player here, let's just do a player.toString, so let's do a console.writeLine on this. If you do this, then naturally this one will throw a null reference exception because player is indeed null. So as a way of doing some kind of initialization, we can write player, then double question marks equals, and then new player. Basically what this does is it's going to check the player variable. If that one is not null, then nothing happens, just continues executing the code afterwards. However, if player is null, if so, then it's going to construct a brand new player and assign it back onto this variable. So this operator can be really great for initialization. Like for example, let's say the player down here has a list of other players to target. And now usually if you have this kind of thing, you can either initialize this list directly on the constructor. That means that the list will be constructed as soon as the player is spawned. However, you can only initialize it when an enemy is added. So if you have a public void add target player, this one receives a player for the target player. And now here, if you just go player target list and add the target player, if you do this, then naturally this is going to throw a null reference exception because this one does not exist. So before this, you can do double question mark equals new list to initialize the list. So basically, if the left side is already initialized, if this one is not null, then this line of code is going to do nothing. But if the left side, if the list is indeed null, if so, then it's going to evaluate the right side, which is going to construct a brand new list and assign it. So this operator is great for initialization, or really just any kind of null check where you want to run some code only if the left side is null. Also, what we covered in the previous lecture, the non-conditional operator. Like I said, that one returns null if the left side is null. So for example, we can do player then question mark in order to make sure we run the code on the right side only if it's not null, then call some kind of function like get player name, and then have double question marks and say unknown player. So basically what this is doing is if the player is not null, then it's going to go inside the player object and call get player name, it's going to return that. However, if the player is null, if so, then this whole thing is going to evaluate into null, and then we have a null, then double question mark and something, so it's basically going to return this one. So if player is null, it's going to return unknown player, but if it is not null, then it's going to return the player name. And by the way, since the whole point of this entire operator, since the point is to do a null check, naturally it can only work on nullable types, like reference types. So if we define an int, if we do this, then naturally this does not work. Whatever's on the left side has to be a nullable type. However, if we make this instead of a regular int into a nullable int, if so, then yep, now this code does indeed work. I'm going to cover nullables in a lecture later on in the advanced section, but basically they allow you to make any type like a bare bones int and make it into nullable. So that's the two null coalescing operators. Another very compact way of doing a null check, in this case to return some value or do some logic if something is indeed null. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to learn about the ternary conditional operator. This is how you can write some super simple if-else statements in a really compact manner. Okay, so this is another simple way to write more compact code. Here I have a function with a regular normal if. It's called getPlayerStateString, just as an if the health is above 0. If so, then it returns an alive string. If not, it returns a dead string. So yep, like this, if the player has 100 health, if it works, the player is alive. And if over here set it to 0, and if it works, the player is dead. So this code works. However, a much more compact way to write literally the exact same thing is like this. We just write the condition without the if keyword. So in this case, health above 0. Then we write a single question mark. And then whatever we want to return if the condition is true. So in this case, we want to return the alive string. And then we write a colon. And then what we want to return if the condition is false. So in this case, we return dead. So you can do this whole thing and then just return it. Basically, this entire thing is going to evaluate into this code if this condition is true, or this code if this condition is false. Which literally means that over here in just this one line of code, we have the exact same logic we have down here. So it really is this simple. Anytime you want to do a super simple if-else, then you can just use this. It is more compact while also being very readable. Now, technically, you can also use it to run some logic. So you write the same thing, then on the right side, instead of just a normal value, you can run some kind of function with some kind of logic. So technically this is valid. However, you have to make sure to either assign it to something or return something, because otherwise like this is not a valid assignment, not a valid instruction. So technically, just to demonstrate how you can run some more custom logic like call a function directly inside of this format. However, for this usage, I would say this is maybe sacrificing a little bit of readability. So personally, I would really not use this. I really only ever use the ternary conditional operator for super simple if-else statements just like this one. And for these, yep, the ternary conditional operator is definitely an excellent way of making them really nice and really compact. So if you can use them without sacrificing readability, definitely go ahead and use them. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn all about the main function in a C# program and how to receive command line arguments. This is very important to know when making normal console apps, doing things that do not have a UI. By using command line arguments, you can still control what exactly you want your program to do. Okay, so we've already been using console apps a lot in this course. It's the easiest way to write and run some C# code. We just make a console app project and we end up pretty much with this code. Then if we run this, yep, there you go, there's our super basic console app. Now by default, it creates this main function. This is our program's entry point, meaning as soon as the program starts running, it will automatically call this function and start running it line by line. It continues doing that until this function terminates, at which point the entire program ends. By the way, in case you're wondering, so how do game engines work if the entry point is just a normal function that runs line by line and eventually terminates? If that's the case, how does a game engine run logic on every single update? And the answer is actually quite simple. So game engines, or really any program that lives for more than just duration of whatever it is doing, usually they have some kind of while loop. So up here, while, either while true do something, and if so, then update some kind of update function. Then when the player presses the quit button, at some point it just breaks out of this cycle, which then terminates this one and terminates the entire program. So it can obviously be more complex than that, but that's the general gist of it. All programs have a single entry point, and then if you want, inside that entry point you can have code that runs constantly non-stop, and at some point the function ends and the program terminates. So main, this is the starting point, and it actually has some very specific requirements. The main one being how it has to be named exactly main. It cannot be called something else. It cannot be called start or even something like main with lowercase. If we do this and we try run, nope, it does not run. We have an error. Here in the error we can see the program does not contain a static main method suitable for an entry point. So the starting main function needs to be named exactly main, exactly like this. Then another very important requirement is how it has to be static. You cannot make this non-static. If we do, yep, there you go, same error again. Main has to be a static function, and that makes perfect sense. So the reason why it has to be static is because when the program first starts, at that beginning you have no objects. There's no instances of anything. So you can't really start by calling a non-static method inside an object because no objects exist. So that is why main has to be static, so that it can be called in the very beginning of the program when no object exists. Then this function also has to be inside some kind of class or struct, and that one can either be static or non-static, both of them work. Main can also have an access modifier. You can make this either private or public, doesn't really matter. Next, for the return type, for this one it can take many forms. So first one is like this, it can simply be void, meaning we don't need to return anything. Or if we want, we can return something, and when we do, then it simply won't execute any more code. So it can either manually return or just let the function end normally. Alternatively, we can make this return an int. Usually this is done if you want to return some kind of exit code from your program. And usually if you return int, returning 0 usually means success, means the program ran correctly, so there were no problems. And if not, if something went wrong, then you want to return some kind of number that refers to some kind of error code. And the other two options for return types are task or task with a generic. This has to do with asynchronous programming. It's how you can have your program execute some logic without blocking the main thread. I cover asynchronous programming in the lecture on async and await if you want to learn more on that particular topic. So here, just know that main can return task, it can be async. But in most cases, you are probably going to do either void or int. And if you do return int and you return some kind of value here, you might be asking, so if this function, if the main function returns something, how exactly do we know what this returns? If we test the code like this, here at top we don't see anything, but here on default console, at the end it says this message, it says our executable exited with code 56, which is exactly the number that we set. Alternatively, we can also execute our program manually. So here I've got the command prompt opened, and over here we can execute the program manually. So just run the executable, and yep, it does say hello world, but we don't see any return code. Now for that, it is actually stored in an environment variable. To access an environment variable, we use the percentage symbol. Then it is named error level, another percentage symbol. So if we want to print this, let's just do an echo on this. And yep, there it is, 56. So whatever value you return from here, you can access this one in order to get exactly what is the error code. So that's the main return, so either void or int, that's usually what you do. And the other important thing about main is over here, the parameters. Here it can have either no parameters, so this is perfectly fine, or you can have some parameters. You can have a string array, and usually by convention it is named args, args for arguments. So this will contain whatever arguments you use when running the program. For testing, let's print out the size of this array, so console, let's do a write line, let's do the args.length. Also, by the way, here, this array, this args, this one is guaranteed to never be null, so there's no need to test for that. Here, let's print out the size of the array, and then let's just cycle through it. So a string r in args, and let's just print it out. So a console.writeLine, writeLine our arg. Okay, so like this, if we run it just over here inside Visual Studio, then we are not passing in any arguments, so naturally it is 0. But now here we are in the command prompt to run our code. And if we run just like this, again, no arguments, it does return 0. Okay, correct. And then for calling it with arguments, we just add a space and then add whatever arguments we want. For example, let's pass in the number 32. And if there you go, it does work. It did receive one argument, and the argument is number 32. Now here we can include as many arguments as you want of any type we want. So for example, for a string, we can include the quotation marks, say code monkey, and then we can include maybe a boolean, so maybe true. And if there it is, 3 arguments, 32, code monkey, and true. In terms of arguments, usually what you might see are some kind of flags. So for example, have a dash debug. This would start the program in debug mode. Or alternatively, you could have an argument like my data.csv. So this would be the file that the program would open to do some kind of analysis. Arguments are really extremely useful when you don't have any kind of UI. When you just want the program to run and just do whatever you want it to do based on whatever arguments it gets. Just like this, don't need any UI, and you can still do quite a lot of things. Now, one very important thing here is how arguments, this one is an array of strings. So over here, when we execute our code with the parameters 32, code monkey, and true, technically that's a number, that's a string, and that's a boolean. But in reality, all of these are strings. So if we want to get an actual number and an actual boolean, if so, we need to parse them. Now, all of the built-in types, they have a parse and try parse function to do that. So for example, for the first one, int dot, let's do a try parse. We can try parse, and for the string, let's grab the args, and the first parameter was the int one. We can do out int, and let's call this the int argument. So you have just like this, basically try parse, this one will return true if it does succeed in parsing and false if it doesn't. And alternatively, we have the parse, and this one assumes that it will succeed. Now I covered these two functions in a bit more detail on the lecture on data types, how you can convert from types back and forth, like converting from a string onto an int and so on. So you can do, for example, this, and then for a bool, let's parse out the one on index 2, and then we can print those. So let's print out a right line, print out the arg int, our int argument, then the second one is actually going to be a string. So let's just grab the one index 1, and then for index 2, that one is going to be our arg bool. So let's see, here run our code, and yep, it did work. We did get the int32, the string code monkey, and the boolean true. So this is how you can convert a string into whatever type you want, and then you can do whatever you want using these. Now, there's actually another alternative for getting some arguments. Technically, you don't have to include the string array over here. You can remove this, and if you do, then you can basically go inside the environment, and inside there's a function called getCommandLineArgs, and this one does exactly the same thing. So let's receive a string like this, args. So like this, our main does not have any parameters, but still, let's try. So here, let's run it. And if it worked, although we got one extra argument, so the very first one is a path to the DLL. So you can either include it directly over here or grab it from this. And this can be quite useful if you don't have access to actually modify the main function. If you can't modify it and it's stuck with no arguments, you can still use this to grab whatever arguments were used. And finally, if you have multiple classes in your code base, for example, let's do a public class, another program. And in this one, if we also define a static void main function as well, if we do this in test, nope, here we have an error. It is saying the program has more than one entry point defined. This is how you can only have a single entry point. There can only be one. You can't have multiple possible entry points. Now we can still do this. We can have a different class that also has something called public static void main. We just can't have two entry points. So if we have this, two classes that both have a static void main, if so, then we just need to define which one we want to be our entry point. So here, let's do a console.writeLine. Let's call it another program. And the way we modify that is over here on the right side. Let's go on the Solution Explorer. Then let's right click on the project. Important, it's on the project, not on the solution. So right click over there on the project. And let's go down into properties. And then it's over here under general that we see the startup object. This one, like says, defines the entry point to be called when the application loads. So it's over here that we can select, and it's basically going to show us the classes that have a main function. So let's say we want to start off from the another program. Yep, just like this. Now let's test. And yep, now it runs and ran exactly starting from that one. Alright, so that's the main function and command line arguments. With this, you can see how you can have quite a bit of control over even some very simple console apps. You can make some very complex programs that do lots of things depending on the arguments they are given. So always remember how you don't necessarily need complex GUIs. For a lot of programs, like just a simple console app, if you just include some arguments, it will likely be simpler and work just as well. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn about Nullable. This is a special built-in type that lets you make any type nullable, even value types like int and bool. Okay, so in a previous lecture, we already learned the difference between value types and reference types. How reference types, like for example a class, they can be set to either null or an instance of that class, but on value types like an int, you cannot set it to null. So over here we can define a player field and set it to null. This works, but if we define an int, nope, this one does not work. Here we have an error. Cannot convert null into an int because it is a non-nullable value type. However, C# does have an interesting thing called nullables, which lets us make anything support null, even value types. And there's two ways to do it. One is very simple. We just add a question mark to the end of the type. Just like this, yep, this one is now a nullable, and now we do not have the error, we can now set it to null. This works with any type, so here we can make a nullable int, we can make a bool nullable. This works. We can also define some kind of struct, define some struct, and over here, if we just have the struct cannot be null, but if we make nullable, yep, that does work. So we can really make anything support null by adding the little question mark, by making it into a nullable. Now this can be really useful if the variable is only used in certain scenarios. Like for example, let's say we had the player and this was some kind of strategy game. So this would be some kind of player unit. And inside you would have an int for some kind of attack damage that the player could deal. And we could define some kind of value if we wanted the player to actually deal some damage. Or alternatively, we could define it as null if we wanted the player to not be able to deal damage. Like let's say they have no weapon equipped. Setting it to null makes more sense than defining the attack damage as either 0 or -1. That makes it a little bit confusing that this specifically means no attack damage, whereas null makes it much more straightforward. This means we have no attack damage. Or alternatively, nullables can also be very useful as function parameters. So for example, let's say we have some kind of setup function. We use this to set up our player. And in here, we can receive an int for the starting health. And if we do it like this, then this one is a mandatory parameter. If we wanted the player to keep whatever health was set in the prefab itself, meaning if we did not want to override it with any kind of starting health, if so, we can just define it as nullable and then default it to null. Again, that would make a lot more sense as opposed to making a normal int defaulting to 0 and then having to remember that, okay, if the health is 0, that means do not override what is on the prefab. Instead, we set it to null, and this one makes quite a lot more sense. So nullables can be quite useful to make literally anything nullable, and if it does have a value, if it is not null, you can just cast it and use the value. So for example, up here we got our I. It can be null or it can have some kind of value. And to grab that, let's say int attack damage, we can grab the value and simply just cast it. Yep, just like this. Although of course this one is going to throw an error if we have null here. So if we do this, yep, naturally we have an error. So in order to do this, before we cast it, we can check if I is not null. If so, then let's actually grab the value. And if it is null, then don't do that. Alternatively, instead of checking it against null itself, if so, we can go inside this one. And inside we have this really interesting property called hasValue. This one, like name implies, is going to be true if a value has been set and false if it's null. So we can check if it has a value. If so, then let's cast it onto our value. Or alternatively, we can also do something instead of doing a cast. So instead of a cast, we can go inside and we can grab direct value. And this one is going to be of whatever type it is, the type that we made nullable. So yep, just like this, no need to test directly against null, no need to cast it, just like this, everything works. Or yet another alternative, we can go inside our nullable, and inside there's a really nice function called getValue or default, and this will either return the value or some kind of default. So we can use this function that returns a default value. So if we put it something like this, like a 12, let's put a console.writeLine on this. Okay, so let's see what this one returns, considering how this one is null. And of course, it returns 12. So that's how we define nullable and how we interact with it. But like I said, there are two ways to do it. This is just one, adding the little question mark. And the other one is to much more explicitly use the nullable class. So there's a class called nullable, just like this. It takes in a generic parameter, so we can do nullable of int just like this. And if that's it, everything else works exactly the same way. It also supports null, it also has the hasValue and the value, it also has this function. Really writing this or adding the little question mark ends up the exact same thing. This one's really just a shorthand, both do the exact same thing. In reality, this class is really just a wrapper around some kind of value. So it has a boolean and has the actual value. So it's essentially just a class with two fields instead of being just one. And then if you want, nullables can also work very well in combination with the null equalizing operator that we saw in a previous lecture. So we can define, let's say, an int nullable, call it a, set it to null, then int b, and let's set it to either a if a is not null, but if a is null, let's set it to, let's say, 56. And if this works, so b will be set to the value of a if a has a value. If not, if a is null, then it will set to the default value. Alright, so that's nullables. Whenever you have some code with some value type and you want to make it support null, then go ahead and use it. It is super simple. You just add a question mark at the end and all of a sudden your code, your field now supports null. Hi there, so quick intermission. Are you enjoying the course? Are you learning quite a lot? I really hope so. I hope you're paying attention. I hope you're taking it slow and really learning everything. Also remember to pause at the end of each lecture and dive deeper into each topic. I made sure to include the titles for all the frequently asked questions, all the quizzes, and the interactive exercises. Those always show up at the end of each lecture, so you can use that to guide yourself. Or you can pick up the premium version of the course to get all that info in the really nice companion project. So if you can't afford it, you can use that page to dive deeper into each topic. But if you can't afford it, the companion project makes it really easy to keep on learning. Alright, so let's keep going. Hello and welcome, I'm your CodeMonkey. In this lecture, we're going to learn about span in C#. This is a really interesting type that lets us do operations on slices of arrays and do so in a super fast performant manner. Okay, so let's see span. This is a really interesting type that was introduced to C# just a few years ago. It allows you to grab a slice of an array and do it super fast and importantly without any memory allocations. That's a crucial part of it. So for example, let's say we have an array of numbers. So an int array for the number array, and we have just a new one, and then just have a whole bunch of numbers, so a whole bunch of random things. Okay, yep, just like this. Now let's say we want to sort this whole array, but we only want to sort the numbers in the middle. We don't want to sort the edge ones. Now one way you could do this is by making a subarray. So you define another array for the subarray. You would define it a new int array, and basically just use the length minus 2. So go into this one, length minus 2. You do this, then copy all of those elements, so only these elements, then sort out this array, then copy them back onto the numbers array. Yep, you could do that, technically that would work. But doing that would also require creating a brand new subarray. This requires allocating additional memory, Depending on how constrained you are in terms of resources, that might be a problem. It allocates new memory, which of course also then has to be garbage collected. So once again, another potential issue for performance problems. So in order to solve that and many other problems, for that we have the span type. A span is really just a slice, or it can actually be an entire array. But importantly, in creating a span, we don't actually allocate any new memory. It is a very special class that is all handled with pointers to the original memory, all done in the background. So the way we create it is actually very simple. We define something of a span. This one is a generic, so let's use a type. In this case, we want the span of int. Let's call it our int span. And then if we want this span to have the entire array, we can just equals it. So equals number array. And if there it is, that does work. So now this span, again, this one is not constructing anything. This one is not constructing a new object. Instead, this span now simply has a pointer to the entire original array. So you can do this if you want the entire array, or in our case, we only want to sort the ones in the middle. So let's grab a subarray. So we can do a new span. This one has a whole bunch of constructors, which first of all receives an array, so that's a number array. And for the start, like I said, I want to start after 1, so let's start on 1. And for the length, so over here we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 elements, minus 2. Let's grab the length of 6. And if that's it, so here we created an int span. So that's a span. It's basically a pointer in memory that is super fast and is pointing just to these elements. And inside the span, we can do whatever we want. Like for example, we can just call the sort function. That's it, very simple. And importantly, by calling this, we don't need to actually update the original array. So we don't need to cycle through the span and update the new array elements. We don't need to do that because, again, this span isn't actually holding any data itself. It's really just a pointer to the original data. So by modifying the data inside of this span, we are also modifying the original data inside the array. So if we do this and then we print out the values, so let's do a for each int number in the number array. Let's do this, and in console.writeLine, let's print out the number. So this should say 5, then all of these should be ordered, and then should have a 10 at the end. Let's see. And yep, correct. So 5, then 0, 2, 12, so these are all sorted, and at the end we have our 10. So yep, we sorted all the elements, but just ones in the middle, exactly as we wanted. And very importantly, we did not have any new memory allocations, which in turn also means we're not going to have any garbage that needs to be collected, which in turn means that our program will be much more stable and much more performant. Then with this span, you can also have all kinds of functions for working with this data. For example, you can copy just a slice onto another span, or copy this entire slice and convert it into an array. You can do a slice of another slice, or you can fill it all with a bunch of elements. And again, all of this applies to the original data. Remember how the span itself isn't actually holding any data, it's really just a pointer to the original data in memory. So in this case, we made a span that takes all the elements in the middle. Now if we call it fill, and we fill it with some kind of value, let's see. And if there it is, just like that. So the original array still has the first and last one unchanged, but the ones we selected, those have been filled with one number. So span is really great for manipulating slices of arrays, again, without any memory cost. Then if you want something even more efficient and you only want to read, if so, then you can actually use a read-only span. And if this one is really the exact same thing, but limits you to read-only, so you can't write to it on this one, you can't fill it. But if all you need is read-only, if you just need that and you need extreme performance, then this one can be a great type. Now spans work on arrays, and a string is really just a char array. So for example, if we have a string, and inside we have some numbers. Let's say, for example, that we worked with some code that contacts a website and that received this string with these values. Now let's say that we want to parse these values. So one way would be to do a substring. So you do str.substring, and over here put the start index and the length. That would work, but once again, we are wasting memory to allocate this temporary string. So if we are building a performance critical application and we don't want to allocate any more memory than we need to, again, we can use a span to slice the string. Although in this case for a string, for this one, using a span doesn't actually work. If we do span char for the char span and do equals str, if we do this, nope, this one does not work. It cannot implicitly convert that one into that one. For strings, it only works the read-only span. And if this one does work, so here we have a span, which again is really just a pointer in memory to this data. So now let's say we want to parse out these values. We can go inside this one. Let's grab a slice on 0, go for a length of 2. And this is going to give us our first number. So we can do int.parse. Let's parse out this number for the int for the number 1. And then for number 2, really same thing. Let's slice starting on 3 and go for 2 more values. So yep, then let's do a console.writeLine. Let's write number 1 and our number 2. Okay, let's see. And if there it is, we do have our 2 separate values. And importantly, just like this, we did not spend any memory allocation cost. Whereas if we had done substrings in order to do the exact same thing, we would have quite a little bit of a cost. Now, one practical example for how this could relate to game development would be perhaps some kind of inventory system where the UI has various pages to show all the items. So you would have some kind of array with all of your items. And then for displaying each page in the UI, instead of creating a brand new temporary array, instead of that, you can just very easily grab a span, just grab a slice of that array, that item array, and use that to display it on the UI. Alright, so that's span. It's a very interesting type for grabbing slices of an array or doing some operations on it without having a memory cost. This is a very useful type in some performance and memory critical applications. Hello and welcome, I'm your CodeMonkey. In this lecture we're going to learn about the bitwise operators in C#. This is how we can do operations on individual bits of data. Okay, so like we covered on the beginner lecture on data types, C# has a bunch of built-in data types. You've got things like short, int, long, and so on. All of these, they all store whole numbers, but their ranges differ. For example, a short can only store 65,000 numbers, then an int can store about 4 billion, and a long can store an insane amount. The difference in all of these is how exactly they are stored in memory, meaning how many bytes or how many bits they actually use. By the way, remember how 1 byte equals 8 bits. So over here, a byte, this one literally uses just 1 byte, so 8 bits, whereas a short uses 16 bits, an int uses 32 bits, and a long uses 64 bits. So for example, here we have a byte in memory. We have 8 bits, meaning 8 zeros or ones. This is how memory actually works. It's all binary in the end. So for example, here we have the number 0, then here we have the number 1 in binary. This is a 2, this is a 3, and so on. Now in case you don't know how binary works, basically every single position on this number, every position represents 2 to the power of something. So this one represents 2 to the power of 0, this one 2 to the power of 1, power of 2, and so on. And those powers equal these values. So this digit over here represents 1, this one represents 2, this one represents 4, and so on. So in binary, you basically just add ones or zeros to whatever number you want to build, and then you just multiply it by whatever is the value on that digit, and simply add them all together. So in this case, this one is a 3, so we've got a 1 over here on the 2 position. So 1 multiplied by 2 is 2, and then a 1 multiplied by 1 is 1, then you do 2 plus 1, and you have 3. If, for example, we wanted to store the number 13, if so, we would have a 1 over here on the 8 position, so that makes 8. Then we would also have a 1 over here on the 4, so that makes 12. And then we would have a 1 on the 1, so yep, this one is 13. This is how you represent 13 in binary. So it's really all just ones and zeros. And the goal with bitwise operators is to basically let you manipulate these bits individually. These are the 4 bitwise operations we can do. We can do an AND, we can do an OR, an XOR, or an exclusive or we can negate. For example, up here we have the number 2, and down here we have the number 3. If we want to do an AND operation between both these, if so, then we just do a normal Boolean operation on each bit, meaning that both of them have to be 1 in order for the output to be 1. So over here we do 0 and 0, and the result of that is going to be 0. This one is also going to be 0, 0, and so on. Then we get to this one, 1 and 1, both are 1, so this one does relate to 1. And then we've got 0 and 1, that one does equal 0. So this whole thing equals a 2. Doing a bitwise AND operation between the number 2 and number 3 equals the number 2. So over here in our code, we can define just the number 2 and define the number 3, and then do a bitwise operation. So we do A and B. Now importantly, it's this one, just 1 ampersand. It is not 2 of them. This one is a Boolean AND, that is not what we want. We want just 1 ampersand to do a bitwise operation. So if like this, let's do a console.writeLine on this one to see what this returns. And if there it is, the number 2, exactly as intended. So what we are doing here is doing an AND operation, but applying the AND to the bits themselves. Another operation we can do is an OR. So this one outputs 1 if either bit is 1. So all of these that are all zeros, these are all going to end up as 0. Then over here we've got 1 or 0, so one of them is 1, so it becomes 1. Then 0 or 1 also becomes 1, and 1 or 1 also becomes 1. So the end result of doing an OR operation between numbers 5 and 3, the end result is the number 7. So yep, let's verify it. Here in the code we have numbers 5 and 3, and now let's do a bitwise OR operation. So just like this, again, just one pipe, it is not 2 of them. We do not want to do a Boolean, we want to do a bitwise OR operation. So let's see like this, and if it's not like that, we do have a 7. Another operation we can do is an exclusive OR. This one outputs 1 if either bit is 1, but not if both are 1. So in this case, all of these are zeros. Then this one, 1 XOR 0, that does equal 1. 0 XOR of 1 equals 1, because again, one of them is 1 and the other one is 0. But on this one, where both are 1, the XOR does equal 0 on this one. So the end result of this one is the number 6. Again, here in the code, let's verify it. So between number 5 and 3, let's do an XOR. And to do that, we use this little symbol. Apparently, this is actually called a caret. In Portuguese, we just call it a hat. So it's this one if we do an XOR between these two values. And if there it is, we do have our 6. And finally, we have the negate. This one, like the name implies, simply inverts all the bits. So a 0 becomes a 1, and over here 1 becomes a 0, 0, 1, 1 into a 0. Here in the code, the way we do a negation is we add a little tilde. We add a tilde before our number. So this is going to negate the number 5, let's see. And if there it is, the number minus 6. By the way, the reason why the number is negative is because of something called 2's complement. This is how the first bit, the leftmost bit, that one is used to denote either positive or negative values. That is also how back here, if we look at all the types that C# has, you can see how we have both signed and unsigned versions. Basically, the signed one, the leftmost bit, is going to define whether it's positive or negative, whereas the unsigned ones, those don't have a concept of positive or negative, so they can only start from 0 towards some positive maximum. Okay, so these are the main bitwise operations, but we can also construct numbers directly from bits. For example, let's say we want to construct here the number 4. So in binary, number 4 is really just a 1 on this position. It's a 1 on the third position, meaning the one on index 2, so this is index 0, index 1, index 2. In order to construct this number, we can use a bit shift. So this is where we start the number, usually 1, because it has zeros on everything except for 1 on here. We start this one, and then we shift it by several places. So in this case, we want to shift by 1 and 2, and we end up with our 4. Now here in the code, like I said, usually we start with the number 1, and then doing a bit shift, we do 2 angle brackets, so 2 less than signs, and then the amount that we want to shift. So in this case, we want to shift by 2 places. So yep, let's see. And if there it is, this equals the number 4. We can also shift in the opposite direction. So let's pick the number 8, let's shift towards the right, and shift by 2 places. And if there it is, we end up with number 2. So manipulating bits is really interesting, but you might be asking yourself, where would you use this in a practical manner? Now, the main thing this gives you is the ability to store a bunch of data in a really compact manner. So you can have each of these bits represent something, like for example, attributes on a gun. For example, let's say that this bit over here, this one represents that the gun deals fire damage. Then this one, let's say that it deals damage over time. And this one perhaps is it causes stun. So with just a single number, with just a single byte with 8 bits, with just that, you can actually store quite a bit of information. So we can store that the gun deals fire damage, deals stun damage, and deals damage over time. Or more practically, Unity actually uses this a lot in layer masks. As you probably already know, game objects belong to a certain layer. You can change the layer here, and you can add a bunch more layers. Also note how there's a specific limit of 32 layers, so from 0 up to 31. That's exactly why, is because the layer, this one is a bit mask. It's a 32-bit bit mask. And in the code, when you do something like a physics raycast, when you do this, note how one of the parameters is an int that represents a layer mask. This is a bit mask, it is not just a single number. So for example, if you want to hit all the objects on layer 6, if so, you would not put a 6 here. Instead, you would define, for example, an int for the units layer. Let's say it's layer 6. And to construct an int for the layer mask, the way you do this is by doing a bit shift. So in this case, 1 and bit shift to the left by the units layer. So just like this layer mask would mean that it would only hit objects on the units layer. Or for example, if you want to hit units and buildings, so let's say we have another for the buildings layer, and this one is on layer 9. If we have this, we can bit shift this one onto the left, and then do an OR operation with 1 bit shift to the left by the buildings layer, and doing an 1 operation. Again, basically it makes 1 when either of them is 1, so it essentially combines 2 layers. And doing so, this layer mask would then hit things on units and or the buildings layer. Or alternatively, instead of all this, Unity actually already has a built-in layer mask type. So up here, let's just make a type of type layer mask. So let's see. And if there it is, we can see a layer mask. And over here, this one shows a really nice drop-down menu so you can easily select all the layers that we want. So for example, select the attackable layer, select the UI layer, the water layer, and so on. So here you can very easily select all the layers that you want. And then Unity automatically constructs a bit mask based on all these layers. Then another place where bitwise operations are used quite a lot is with enum flags. And that's actually what we're going to cover in detail in the next lecture. Alright, so here we learned about bitwise operators, how we can manipulate individual bits in our data. This is an excellent way to store some data in a really compact manner. With just a single byte, you can store quite a lot of information.